Welcome to lecture 7 of electronic devices and circuits EDC. Today we'll compare fixed bias versus emitter bias configuration of a BJT. This is the fixed bias configuration where we do not have an emitter resistor. In the emitter biased configuration we do have an emitter resistor. That is the basic difference. IB, the current flowing, we have already studied that the current IB flowing through this fixed bias circuit is this VCC minus the voltage drop across this base emitter junction, which is 0.7 mostly, divided by RB. Whereas for this emitter bias circuit, we have already studied it's VCC minus VBE over RB plus beta times RE, where this factor RE, this emitter resistor, once seen in the input on the input side, it multiplies with beta. I say in both cases it is beta times IB. If you put the value of IB here, if you put the actual value of IB here from this earlier equation, this becomes beta times VCC minus VBE over RB. Whereas if we put this IB here, it's VCC minus VBE over RB plus beta RE. We can see that here we have a beta in the numerator and a beta in a denominator. So this tends to cancel the effect of beta, and IC tends to be somewhat independent, not completely, somewhat independent of beta. We can verify it numerically too. But for this fixed bias circuit, this beta is in the numerator. This means that whatever, if there is a change in beta, the same change will be reflected in IC for this fixed bias circuit, making less stable versus variations in beta. With the help of a numerical example, we will shortly see that emitter bias circuit tends to be more stable compared versus variations in beta. Let's solve a numerical example. I am giving a circuit where VCC is 20 volts, RP is 430K, RC is 2K, RE resistor is 1K for emitter bias circuit, and beta, we are given two values of beta is equal to 50 and beta is equal to 100. And we'll see that for these increasing values of beta, IC, we'll compare IC, the collector currents for these two circuits. Let's make a small table. I have in my worksheet, I have put these values in these expressions and have computed IB and IC for these two circuits. So now I will draw these tables. For fixed bias circuit where we do not have an emitter resistor, beta IB in microamperes and IC in milliamperes. If we put the value of beta is equal to 50, IB is 44.8 microamperes and IC is 2.24 milliamperes. But if we increase the value of beta to see how stable is IC versus variations in beta, IB remains the same, 44.8 micro, and IC becomes 4.48 milli. So percentage change for fixed bias circuit, there is no change. or this change is not significant because IP doesn't set the operating point of the transistor. And there is a 29% 29% 29% increase. Sorry, there is a 100 from 2.24 to 4.48. There is a 100% increase in IC for an emitter bias circuit. If we try the same values to see how stable is emitter bias circuit with respect to variations in beta. Beta is 50, IP is 40.2, IC is 2.01 milli, and for beta is equal to 100, this is 3.63 milli. So percentage change is 80%. So we conclude that IC, the collector current for emitter bias circuit, has changed by 80% if we double the value of beta, and for the same change in beta, the fixed bias for the fixed bias circuit, IC changes by 100%. This means that emitter bias is more stable compared to variation, has a more stable bias point compared to more stable bias point versus variations in beta compared to the fixed bias configuration. Thank you.